So 2C.12, we're going to be applying our log properties to be able to evaluate and simplify log expressions and equations. These were the properties of logs that we learned. There you have your regular base log, and then you have your natural base log, which is ln, and the properties are the same for both. So if you look up here, remember for product is very similar to the product for exponent rules, right? If you are if you're multiplying two factors within your argument, you can separate them into two addition problems. Okay. What this allows you to do is to separate your variable from your numbers. And then you can vice versa. When we're going this way, we call that expand. When we're going this way, we call that condensing. Ringing some bells, expanding and condensing logs. Sure. Okay. All right. Quotient means that you have two things that are being divided within your argument, and those two things that are being divided can be separated through subtraction. Okay? And then power is that your power of your argument can become the coefficient of your log. All right, let's apply our laws, our properties. Up first, so here we're going to expand. All right. And so with expanding, we decide which rule can we use to expand. I like doing these because I don't know, I feel like it's a puzzle. It's like a math puzzle, and I like puzzles. Don't judge me. Am I on the pin? There we go. All right, so which property am I going to use to expand? Product. I'm using the product property because these are factors. They're all being multiplied. Because I'm using product property, that means that now each one is going to become their own log. So I have log 8 plus log x plus log y to the 4th. Now I'm going to ask myself, self, is there another property that can be applied? And self is like, oh yeah, you have a power. I use myself. Okay. And I'm going to apply the power property. The power property tells me that I can take my power and it becomes my leading coefficient. So we end up with log 8, well, my coefficient, I'll leave it the same. Log x plus 4 log y. And now I have fully expanded. Please tell me this is ringing a bell or two. Somewhat. I can't say that. What is it, terrible? Okay. B is a little different. B's a little work that we got to do. Okay. So on B, notice that we have a radical. Does anyone remember how to change a radical into a power? Okay. A radical means that you have a rational power. So the square root means that I have a power of 1/2. Does that ring a bell? A little bit. So this is also can be written as natural log of parenthesis x squared plus 5 to the 1/2. All over x. So now we're going to work with it, what we have. Okay. I'm going to draw a little line of separation so I don't cross over. Which rule am I using? Quotient. Because I'm using quotient property, that means I'm going to separate these two by what operation? Subtraction. So it becomes the natural log of parentheses x squared plus 5 to the 1/2 minus the natural log of x. And then I'm going to check for which property? Power. Can I apply the power? So I'm going to apply the power property, which now makes this into 1/2 natural log of x squared plus 5 minus natural log of x. And that is all you're doing. Okay, so that's expanding. Now we're going to condense. So we're going to go backwards. So notice with expanding, the last thing we did was power, right? With condensing, the first thing you're going to check is for is power. Does that make sense? Because we're going opposite. We're going the inverse of that, right? So first we're going to check for power, and then we decide between quotient and product. Make sense? All right. So on our example number 2, we're going to check for all power play. So you're going to start off with power. Well, this one's already been done, but has this one been done? No. So then I'm going to apply the power rule. So I'm going to be left with natural log of x to the 5 minus natural log of x times y squared. After you've applied the power rule, now you're going to decide, is it product or quotient? And why is it quotient? Subtraction. So they're going to have 1 log, natural log. Your numerator is your first term, which is x to the 5th. Your denominator is the argument from your second term, which would be xy squared. Okay, the difference with condensing is we have an added step. The added step is to simplify. Okay, after you've done that, you're going to simplify, meaning that if there's anything that can be combined or eliminated, you have to combine and eliminate. Does that make sense? Okay, so when you look here, in my numerator, I have 5 x's. In my denominator, I have 2 x's. So what can I condense? My x's, right? So my final answer would actually be the natural log of x to the 3rd over y squared, because the 2 x's in the denominator would eliminate. Okay, guess whose turn is to try? Oh my gosh, you're so smart. And go, little birdies, fly. What do you mean, go ahead? I mean, go ahead and do it. Ready, Curtis? I believe in you. I believe in all of your abilities. Then you dust yourself off and try again. That's what Aaliyah said. All right. So remember, you always start with what property first? Power. So I'm going to apply the power property. Notice that that power property goes to everybody, right? Everybody that's in the argument gets that power. Okay. So we end up with the natural log of x to the third y to the third time. Is it okay if I just leave it like that with a bullet and you'll understand? Times natural log, not natural log, times, what is it? Y z squared squared. And I'm going to go ahead and distribute my powers. So I have natural log of x to the 9, y to the 3 times y squared z to the 4. Which leaves me with the final answer of natural log of x to the 9, y to the 5, z to the 4. How we do? Didn't expect the exponent rule. Can't forget those. All right. Any questions about these three properties? Power, quotient, product. Any questions about power, quotient, product? No? All right. Let's talk about change of base. All right. So change of base is a little outdated, meaning that because of Desmos, because of graphic scientific calculators, most calculators allow you to change base, right? However, it is still useful when you are evaluating, all right? So yes, you can type in whatever base you want in these devices, but when you're evaluating or you don't have access to a calculator, then this rule comes into somewhat of help. All right, change of base basically states that if you have a log function, you can write it as two separate log functions of any base that you need it to be, as long as it's the log of the argument in the numerator and the log of the base in the denominator. Okay. So it has to be the log of the argument in the numerator and the base is in the denominator, which I just remember the base is in the basement. The base is in the basement, and the other one has to be in the numerator. Okay. Remember base 10, this is our common log. That's a weird M, but we're going to roll with it. And base E, this is our natural log. Okay. So let's apply change of base. So looking right here, we have log base 3 of 13. And let's say I just wanted to be with common log. So I wanted to write this using common log. If I wanted to write this using common log, that means I don't want to have the base 3. I just want log. And again, it's the log of your argument divided by the log of your base. That's it. Or you can use natural log, which would just be ln 13 divided by ln of 3. This takes a problem that you may not have been able to do on your phone in scientific and turns it into a problem that you can do on your phone in scientific. You know, when you turn your phone, it becomes scientific. And so that's all it is. That's change of base. We went over it last year as well. Y'all remember it a little bit? All right. So really quick, B and C, what would this be as a common? There we go. As a natural log of 10 over natural log of 6. Beautiful. C, common. Why are you only answering me? It's concerning. Thank you. Or your natural log of 2 over, that's it. Yeah, we're gonna roll with it. All right. Yay, change your base. Questions about changing base. Can you take anything and turn it into the common and natural? Yes, you're geniuses. I knew it. All right. So let's talk about. All right. So we're gonna pick off here where we're gonna pick up where we left off at, which was talking about how transformations, because of log properties, certain transformations are interchangeable given the function. And this kind of goes back to us in pre-AP Algebra 2, where we did the same thing with exponentials and logs. Why do I know that? Because I'm currently doing it right now with this group of students. So if you look right here on example number 4, we graphed our log function, our parent function. So the parent function that we graphed is y equals log base 2 of x. Log base 2 of x, remember saying 2 to what power equals this, right? So 2 to the 0 power equals 1. Therefore, when we graph this, we grow 1, 0, because that's the inverse of that. And so we plotted our points. Here are our points. Now, it says to use the product property to show this is a vertical translation. So to start off with, we have log base 2 of 4x. Log base 2 of 4x is what's the transformation, initial transformation? If I have 4x, what kind of transformation is that? What kind of dial on what? It's a horizontal dilation, right? So we have a horizontal dilation, and x's are liars. So it's not by 4, by a factor of 1/4. Because our x's are liars. So it looks like we're actually at 4, but we're actually at dilated by 1/4. Okay, that's our current position that we're in. So what that means is that if I was to take all of my x values and cut them by 4, like divide them by 4, that would be my new home. Does that make sense? So for example, here, I'm currently at 1, 0. Well, what's 1 divided by 4? 1/4. So it would be over here at now 1/4, 0. Does that make sense? Are you with me? Okay, this one is at 2, 1. So currently at 2, 1. So if I'm at 2, 1, 2 divided by 4 would be 1/2. So 1/2 would now be at 1. Okay, 4 is at 2. What's 4 divided by 4? 1. So now we'll be at 1, 2. 8. 8 divided by 4 is 2. So we'll be at 2, 3. So this would be our horizontal translation. I'm going to do my very best to draw this as if I'm a calculator. Okay, that's it as a horizontal dilation. Do you see how this could also be considered a vertical translation after looking at it? Right? So let's say, how does that work mathematically? So how does this work out to be a vertical translation mathematically? Well, when you have log base 2 of 4x, we can expand that. And that expands to become log base 2 of 4 plus log base 2 of x. So when I expand g of x, I now have a vertical translation. I have a vertical translation of log base 2 of 4. And what is log base 2 of 4? Two to what power is 4? It's 2. So this becomes 2 plus log base 2 of x is equivalent to log base 2 of 4x. Depending on which one you have, you're going to describe the transformation differently. Does that make sense? But they're exactly the same. So when I'm the first one, this is a vertical translation up 2, right? But when I'm here, I'm a horizontal dilation by 1/4. And that's because of that expanding and condensing property of log. So in condensed form, I'm a dilation. In expanded form, I become a translation. I know. Math is crazy. I tell you. All right, so let's look at it for ourselves on a graph. I'm going to reset this. So I'm going to put in first our log function. Y equals log shift dash base 2. That's not a 2. That's a z. Of x. So there's the original, right? Now I'm going to put in y equals log shift dash base 2 parenthesis 4x. Is that not what we graphed on our paper? Now notice when we put in our translation, y equals 2 plus log shift log base 2 of x. That's another x. I don't know why. That's not even where 2 is located. And what did it do to my blue graph? It's the same. It just overlapped it. They're coinciding because they're equivalent. Okay? So one is condensed and one is expanded. And depending on what you're given to, you're going to describe the transformation differently. That's the conclusion of our log properties and how they translate over into the transformation of the log function. All right? Make sense? All right.
Decline. This is Cadet First Sergeant.